Thank you all for joining today's webinar. My name is Rahul and I am the Staff Specialist Technical Support Analyst working with the BMC Client Management product. So before we start, let's walk through the agenda for the webinar. For those that are not aware, OSD means Operating System Deployment. In today's webinar, we will discuss the why and how of OSD, its architecture, workflow, and components. We will also look at how to initialize and set up the OSD manager and conclude with how to build and deploy a test project and the necessary references. Why should we use OSD with client management? Centralized management for images, projects, drivers, and targets, the use of the internal DHCP gateway, the OSD Pixie menu, drivers by model, and the ability to have network boot listener and image repository at various sites to perform multi-site deployment are the key features of using OSD with client management. The OSD architecture. This is a common use case and example setup of the OSD architecture. A single OSD manager, one network boot listener per subnet, and image repositories at each physical site form the foundation of the new OSD architecture. There are three main phases to the deployment of an operating system, each involving multiple tasks. The preparation phase, the files needed for the actual deployment as well as the environment required by the OSD manager are prepared at this phase. It also includes the setting up and making of the OSD required components like the disk configuration and drivers. The project phase, the real deployment project is created at this phase, which also involves the project's construction and the selection of its component parts. The execution phase. The phase is included to confirm that all target devices are correctly installed, operational, and monitoring the network status following the remote installation. So, what are the prerequisites for using the OSD module? For OSD, there are 6 primary prerequisites. They are, of course, the operating system deployment license, the OSD manager, which needs to be a Windows device. We prefer Windows Server. The image repository, the network boot listener, and last but not the least, Windows ADK and the WinPE add-on for ADK. Please note that starting from Windows ADK 1809, WinPE is not bundled with Windows ADK and is available as a separate download. BMC Client Management's OSD module requires the cooperation of several distinct elements and objects. They are as follows. The device that is in charge of developing and publishing deployment projects is called the OSD manager. Although having more than one OSD manager is possible, it is advised to have just one. By default, the OSD manager serves as the network boot listener and image repository. Since it is the parent of all ensuing image repositories, the image repository role is required. Next, the link that connects the targets and the OSD manager is image repositories. They are given OSD items such as projects, images, and so forth. As a result, the repositories need a lot of disk space to keep the data because they cache the objects. Multiple network boot listeners, one for each subnet, should be present in every repository. Relays are suggested as the image repositories. An image repository should have the OSD manager as its parent, or in more complicated setups, another repository. If a node has no children, it is possible to deactivate the image repository, in which case it turns into a network boot listener. The actual deployment is carried out by the network boot listener, which notifies the targets and gives them the connection to the installation source's data. Storage device. This device has network shares that can be used to store custom images, web images, and OS configuration files for deployment. It is recommended to use a Windows Server edition or a Linux server with a Samba share. The storage device may be on the DHCP or TFTP server, or it may be a standalone device. The NAMP user. The OSD module establishes a local administrator named NAMP user in order to access the Windows network shares specified in the image objects. The BCM service can access and verify the supplied UNC path and credentials by using the network share APIs, which are made possible by the NAMP user account. On the OSD Manager, it is also utilized to cache the image content. Additionally, the Windows ADK installation on the OSD Manager is performed by the NAMP user account. It is advised by BMC that you manually install Windows ADK on Windows domain controllers, as running the OSD Manager on a Windows domain controller may hinder NAMP user from installing Windows ADK correctly. Projects serve as the hub for gathering each component needed for the installation of an operating system. It obtains all of the data through these components, which are subsequently combined during the project construction phase. Following a successful completion of this process, the project is published and activated, meaning that the target devices can install it since all necessary data has been made available. OSD drivers. All of the drivers that are defined for operating system deployment are accessible through the drivers node. The drivers node is further classified into four different types or classes. Deployment drivers. These are the drivers that WinPE needs in order for them to be installed. Operating system drivers. Operating system drivers such as keyboard and mouse drivers, audio and video drivers, modem drivers, and so on are drivers that an operating system may need in order to work normally once it has been installed on the target devices. Drivers by model. Folders titled Drivers by Model hold all of the drivers relevant to a certain hardware model. Driver tags. In order to facilitate their selection for project assignments, drivers are categorized using driver tags based on their goals. With that, I'm now going to move over to my demo on adding model-specific drivers to the driver by model node. To add drivers to the drivers by model node for a specific model, we need to first find the model name of the device. To find the hardware model name, we will use the inbuilt standalone VB script. This script can be found on any client device with the BCM agent installed on it. The script can be found in the installation drive in the client data OS deployment model name directory. Run the model name.vbs script. On running the script, it will provide the model name of the device on which it is run. Here we get the PC model as Latitude 5411. In the client management console, go to the OS deployment module, the OSD manager, drivers, drivers by model. Right-click on drivers by model and select create directory. Enter latitude 5411 and click OK. Now we have the directory created for drivers of model latitude 5411. To transfer the driver files to the latitude 5411 directory, right-click on drivers by model, select file transfer. The file transfer window will open, which will allow us to copy the driver files to the OSD Manager device. In the left window, select the driver files, select the target directory on the OSD Manager, and click the arrow between the two boxes to start the transfer. Select Close when the required files have been transferred. When adding drivers for the first time or making any changes to the drivers by model, the files need to be scanned to make projects aware of these changes by default. To do so, right-click on Drivers by Model and select Scan Drivers by Model. On the confirmation window, select Yes. This will start the scan. Select Close. We now see that the respective drivers have been added to the drivers by model directory for latitude 5411. With this, we complete the demo of drivers by model. OSD images. Images are the objects that have all the fundamental data needed to access the setup files or the Vim or custom image that needs to be installed on the intended device. There are three basic modes for images. They are setup mode, Vim image mode, and custom mode. As soon as the first image of a type is created, the nodes for that type of image are immediately constructed. With that, I am now going to move over to my demo on adding an image. The Images node provides access to all images which are defined for the operating system deployment. We will now look at how to add standard Vim image. To do so, in the Client Management console, go to the OS Deployment node, go to the OSD Manager, Images, select Standard Vim image, right-click, and select Create Image. Enter the name of the image. The description field is optional, and you can, in the architecture field, select the type of architecture for which the image is to be desired. Here we select 64-bit. Select the supported BIOS type, which can be either of the three mentioned types. Here we will select Legacy and UEFI. In the type, select Standard Vim image. In the location field, we will enter the location of the image, that is the network UNC path where the image resides. Next, we mention the connection parameters, that is, the login and password to be used by deploying device to access the network location in which the image resides. To do this, we click on Edit and enter the login details. The login should be mentioned in either of the formats, that is, domain followed by username, or in our case, local host name followed by username. Click OK. Click Check Image to the right of the status field to verify the details mentioned on this page. If the details mentioned are correct, the status OK is returned. Click OK to confirm the new image. We see that the image is now added under the standard Vim image node, which can be used by projects for deployment. With that, we complete the demo of adding an image in OSD. OSD target lists. A target list contains all the devices to which the deployment is to be assigned. If the target list is defined by a subnet mask, this list will be filled in dynamically and the devices will add themselves once they are booted. This list is updated every 4 minutes by default. Devices can be added to the list of targets through a number of different ways. They can be added via auto-discovered objects, auto-discovered devices, Microsoft Neighborhood Network, and CSV list. One can also create target devices. This can be done by specifying one of the three allowed options. They are the target's data that can either be MAC address, the IP, or the DNS of the target device, the Pixie subnet filter, and the Pixie menu. Now we shall move over to the demo on how to create a target. In order to create target, we first need to create a target list. In the Client Management console, go to the OS Deployment node, OSD Manager, Target Lists. Right-click on Target Lists and select Create Target List. Give a name to the target list. The description is optional. Select the architecture. To create a new target, select Create a new target. Enter the desired target information. Here we will enter the Pixie subnet filter. The Pixie subnet filter will target the entire subnet. When we use the Pixie subnet filter, we can provide a name to be assigned to the target device on which the OS is deployed and a suffix counter to start from. For each device connecting within the scope of the Pixie subnet filter, the suffix counter will be incremented by 1. If a suffix counter is not desired, one can also use the target device's serial number as the target name's suffix. Click OK. The target list with the targets has been created. With this, we complete the demo of creating a target in OSD. OSD deployment options. There are multiple ways to deploy the operating system on the targets. These consist of deploying directly on the target over the LAN, using the Pixie subnet filter, using the Pixie menu, and deploying directly via USB storage, DHCP scopes, options 66 and 67. Option 66 corresponds to the boot server host name, whereas option 67 corresponds to the boot file name. When a target device PXE boots, a boot file is sent to the target based on the BIOS firmware, which can either be legacy BIOS or UEFI. The internal DHCP gateway will provide the respective boot file to the target device, and there is no need to specify options 66 and 67. If you do not wish to use the internal DHCP gateway, one needs to specify the DHCP options 66 and 67, which are defined in the respective DHCP scopes. For option 66, you need to mention the OSD boot listener IP address for the respective scope. For option 67, you need to mention the respective boot file name based on the target device's BIOS firmware. A drawback of using your own DHCP server instead of the internal DHCP gateway is that only one boot file can be mentioned either for legacy BIOS or UEFI, and this needs to be changed every time the target BIOS firmware changes. Now we shall move over to the demo and see how to add a new OSD manager and initialize it. In the Client Management console, go to OS Deployment, right-click and select Add OSD Manager. Here I will be adding the master as the OSD manager. Click OK. The OS deployment module has now been enabled on the master. To further set up the OSD manager, expand the OSD manager device, go to Configuration, right-click and select Properties. If the OSD manager device is connected to the internet, we can directly install Windows ADK via the Install Windows ADK option. Click Yes. This will take some time. You can check the status of the Windows ADK installation by clicking the Refresh Status button. On refreshing the status, we see that Windows ADK is installed. Once Windows ADK shows as installed, click on the Check Environment button. Do remember that the definition of the OSD manager cannot be completed until the environment check completes without errors and the status shows OK. In the image repository parameters, you can enter the storage path. This should be the path for the storage location for all of the necessary OSD data. Under the parameters for the network boot listener, you can choose the option to use the internal DHCP gateway, and if you do not wish to use the internal DHCP gateway, you can uncheck the Use Internal DHCP Gateway option and mention the DHCP server address. Once you have entered all of the data, click on OK. We see that the initialization is complete and this is shown under the initialization status. Now you can start creating projects when the initialization has been completed. With this, we conclude the demo of setting up and initializing the OSD manager. We shall now move on to the last demo of this webinar, that is creating and deploying a test project. To create a test project, go to the OS deployment node, the OSD manager, right-click on configuration, go to properties, select create new test project. In the scope, we need to enter the PXE subnet filter for which the scope has been defined. Click OK. The test project will be created. We see that the test project has been built successfully and the build status shows build completed successfully. We shall now pixie boot the target device and see how the test project is deployed on it. We see that the target device has received the boot files. This is the WinPE phase for OSD in Client Management. It will now download the project. The command that we see on the screen is run when we deploy any project that is created using BMC's OS deployment module. We now see that the test deployment has been completed and it says that the OSD manager is fully functional, which means the test deployment was successful. This method can also be used to identify the model name of any target device. As we see in this case, since it's a virtual machine, the PC model name comes up as virtual machine. With this, we complete the demo of creating and deploying a test project. To summarize today's webinar on OSD, we have covered the advantages of using OSD with client management, its architecture and phases, the prerequisites, various components of OSD, along with a few demos, and we also saw how to initialize and set up the OSD manager, along with creating and deploying a test project. In the upcoming months, we will have another webinar, which would be a more detailed session on OSD, which would include topics like creating OSD projects via the project creation wizard, how to sysprep and capture an image, along with how to deploy the captured image with some common troubleshooting scenarios. Here I have added the necessary references to the BMC docs and a few knowledge articles. Well, that sums up our OSD webinar for today. Thank you all.